Hey everyone, in this video I'm going to tell you guys about our project, which is Model Fairness and Transparency. It is very important to ensure the fairness of a ML model because the model will then impact real-time decisions. We need to find out if there's a bias and we need to remove it. For the model to be fair, we explored the COMPAS dataset in which the model was predicting an Afro-American over a Native American to commit a crime in the future, which was found to be false when observed. But here comes the question. Why were these predictions biased and what could have been done to remove the bias from this model? So we started working on this. We collected the COMPAS data from Kaggle and cleaned it using Python libraries and then detected the presence of a bias in the dataset. Now we had to somehow remove the bias. We chose reweighing technique to do so. In the end, we obviously had to make sure that our model was transparent. So we took help of the very two famous inspecting tools, SHAP and the Google What If tool. This is how our data pipeline came along. Now let's go a little deeper on how all of this was done. We ran two different models with original data and found out that the disparate values were below 0.8, which was the threshold. The acceptable range is between 0.8 to 1.2. To further analyze the biasness, we made good use of Google What If tool. Initially, the predicted data point was Native American and the predicted value was 0.55. But then it was changed to Afro-American and the prediction of committing a crime increased to 0.67. When further analyzing using the confusion matrix, we found out that the number of false predictions for Afro-Americans was more. This made us sure that there was a bias in the model. Now how do we remove this bias? We can remove a bias either in pre-processing or during training or after predicting. For our project, we used a reweighing algorithm in the pre-processing stage to remove the bias. As a result, we can see that the disparate values have increased and now are within the acceptable range. Both average odds difference and equality of opportunity are closer to zero now, which means that both privileged and underprivileged groups have equal benefits. This is the metrics for a result of original data versus the transformed data. We can see that as a result of bias removal, the misclassification has reduced while using transformed data. To gain more transparency of the model, we use SHAP. Here, the red color shows us the positive impact and the blue shows the negative impact. And the two most important features were decile score and prior count. These are a few dependency plots for SHAP. AI and ML models are good as data it trains on. If there's bias in the data, the model learns accordingly and can make decisions which can be biased towards a particular attribute. Project, we learned about tools like IBM 360, Google What If, and how to identify and mitigate bias using them. We applied reweighing algorithm to remove bias and used SHAP to evaluate the model's fairness. Thank you, and these are my teammates.